well. Okay, my name is Andy Emerson. I can see a few people who are logged in who I do know, so welcome to you, but also welcome to everybody else who hasn't previously spoken with me. The purpose of this afternoon's quite short webinar is to talk about linking Witness and Excel, and it's one of our series of Beyond Modelling webinars. I don't have a great deal of time, so I'm going to restrict myself to showing you two models, and I'm going to start with, hopefully everyone can see, there's a model called Run Witness 13 from Excel, and this is the latest simple interface that we have through which we can set up multiple replications in Excel, specify our run length, our warm-up time, our number of replications, and if we have Witness 13C or beyond, and if we have a PC with multi-core capability, then we can run multiple replications at the same time, which can of course save a considerable amount of time. Traditionally, if we take the clock back a few years, we've been able to link to Excel for some time, usually running it from Witness. The model that is visible here is accessible off the LANA portal, so if you are a maintained customer you can get hold of it. There is also a blog which I wrote a few weeks ago which talks about the simple experimentation using the method I'm going to talk through during part of today's session. So you can get that by going to the LANA website, clicking on blog, and you can download, and you don't need to be a maintained customer to do that. If we look at the Witness model in front of us, quite a simple model which has some data. Now if I'll rewind it to time 0, we can see all the variable arrays displayed on the screen go blank. In the Excel spreadsheet I have a data sheet which has information that I wish to import directly into Excel, and I will do this using the standard Excel read array command. Those of you familiar with Witness will know there are a host of commands, around about 30 commands to link Witness to Excel, but generally we can get away with only using two, the Excel read array and the Excel write array. In this case I have chosen to use named ranges, which is a very useful feature in Excel because it does mean I can cut and paste this set of data somewhere else within my Excel worksheet, and the named range we can see in the top here is preserved, and therefore we can move data around without risking breaking any links. So any of you who do use Excel links, I would urge you or recommend you to consider using named ranges as a method of increasing the robustness of the communications between Witness and Excel. In this model I have 5 part types, P1 through P5, which have a series of routes through the model. As you can see, P1 goes through the machines op02 to op08, P5 from op02 to op07, and I can add and change routings within Excel. I have cycle times as well in a lookup table, so all I need to do in Witness is to look at the part index number and the next operation number in that part's route through the model, and it will pick up the cycle time accordingly. If I go into Witness and set the model running, first of all I'm prompted for the model name, and I'll come back to that in just one moment, and then it reads the information into the model and starts running it through. And we can see the 5 different part types which are color coded, so I hope none of you are colorblind, pass through the model in different combination, different routings, taking the appropriate cycle times. And what I'm recording in this case is a number of parts shipped, which we can see in a variable towards the top right of the screen, and I'm also looking at the maximum queuing that takes place in front of each of the operations as some simple reports that I wish to collect and write out to Excel. I'm going to translate into the fast forward button to run the model through, and when it gets to the end of the time, the reports are exported out to Excel. And if I just drag this window down a little bit, we can see the number shipped in Witness is matched by the number shipped in Excel. And again, if you check the numbers down the right hand side of the column here, you will see they correspond. So I've taken a result at the end of the model run and exported it directly to Excel. Okay, so I've brought data in and I've taken data out. If we take a look at the Witness model, those of you familiar with the Witness will know that the first thing that happens is the model enters initialize actions at time 0. And in here I set up the initial conditions. I could put it all into this one window, but it's good practice to separate discrete pieces of code that have unique purposes out to make the model more maintainable. So I'm calling two functions in turn. If I go into the first function, this is simply one that sets the file name of the model. If I am running this model from Excel, the Excel file name will be passed in automatically, and therefore this piece of code will not be executed. When running it from Witness, the initial value of the variable is 0, and so then I can offer the default workbook name, and then a message dialog opens, which you would have seen when I first ran the model, which invites a user to change it if they wish. It's by no means necessary to do this, but it does give you a little extra control. After that, I go into my initialize routine, which is reading in the information from Excel. The name of the workbook was preset in the previous function, and now I'm specifying the name of the worksheet that I want to look at, and then I use the Excel read array command. Now, this is a very simple command, and I'll do in the next model. I'll show you how you can create it from scratch if you haven't got familiarity with it. In this case, I'm using the name of the worksheet, the VS Workbook, and the VS Worksheet as wildcards, so that I can change the name of my worksheet, I can change the name of my workbook, and the value will be automatically substituted. Therefore, I do not need to change anywhere else, so I can have multiple reading commands, and a change in the name of the workbook will ripple through. We can see here the named range. I've chosen to use the data grid, which I highlighted a few minutes ago. So it goes into the workbook that we specified, into the sheet that's specified, finds that named range and puts the value into the variable array VRCT matrix. And it does the same for a few other sets of data. It also sets the arrival time, and then I run a standard set info command in order to drive those values into Witness. The reason we have to use a set info in this case is Witness is configured to try and protect us from making changes that could be dangerous, and trying to manually change or use a variable to set the first arrival time of a part is deemed to be a dangerous thing to do, and therefore to protect us from ourselves, that kind of functionality is disabled. But there is a way around it, as you can see. If anybody wants to know more about that, then if you put a chat message in, and we will get back to you with some more information after this webinar, but it's not part of the Excel webinar. Similarly, I read in the run duration and the warm-up period, and we can see that from our control sheet. The run duration again is a named range. Doesn't have to be, but it's just neater than using explicit cell references, which could be compromised. The warm-up time also is set there, and then I use a set info again to drive the warm-up time into Witness model. And the result is the model then takes that data and runs forward. On completion of the model run, at the end of my run period, I use an Excel write array to export the reports, and the information I'm putting out is things such as the number of parts shipped to each of the scenarios. Okay, let me close the Witness model now, and I shan't save it, and I shall return to my Excel. And in here we can see that our front end, which allows us to run replications in a simple way, we have the name of the model specified, we have our decisions of run length and whether they're going to run or batch, the number of replications we wish to do, the number of cores we wish to use on our machine, and the random number stream skip option so that we do put variability into our model. We then have a run witness macro, which, if we look at it very quickly, contains some fairly straightforward code to set up the model run. And you can see information here such as a model name, the number of replications, the duration, the random number stream skip, etc. in order to set our model running. But there aren't that many lines of code in order to fire at witness, open up the model we want, and to run it for the requisite period of time. So if I press the button, witness will then start being processed, and you can see a message comes up to say it's initialized the model, scenario has started, and if you look over to the left hand side of the screen we will see versions of witness opening up. So I click the scenario started button. I'm going to switch to my reports mode so we can see reports appearing, and we can see on here we now have multiple versions of witness being opened and run, 4 at a time, and reports being written out to Excel. So this does give us the ability to run models far more quickly than if we were just running one replication at a time. Okay, this spreadsheet and model are available on the portal for those people who are maintained users, and again, if anybody wants a bit more information on it, then we'll follow up outside of this webinar. Okay, I'm going to move from this model now because time is running on, and switch into a simpler model to show those of you who maybe are not so familiar with the Witness Excel links how we can enact them. So I'm just going to close my model and I will go to Witness, and I shall open up another model, which is one that is based upon the training course that we run, our 4-day basic training course. And I shall go and open Excel as well, and in fact I'm going to open an older version of Excel because that happens to be when I wrote this what the version was in. So we can use any version of Excel, 2003, 2007, 2012. I'm going to enter my, just bear with me while I navigate to where I want to get to. My witness training 2013, simple links, and here is a spreadsheet. In this spreadsheet I have some data to enter in, which is cycle time, mean time between failure, and mean time to repair for a machine M3, which is the one that is coloured the blue shade, and is one machine of quantity 2. So we can see in the element selector on the left we have 2 M3 machines. So what I need to do to read this data in is to create a variable array. If I can just get my Excel, oops, where's my Excel gone? There we go. I need to create a variable array to read this data in. So here I've created a 2-dimensional variable array, 2 by 3, and if I look at my model initialize actions, then we can see I have an Excel read array command. If I was to make this from a starting point of little knowledge, then my easiest option is to go onto my variable array, enter actions on initialize, and in many parts in Witness we have an Excel button which allows us to link into our workbook. And as soon as I click on that, I get a dialog box up which asks me to select the cells I want. I select them and I click OK, and we can see automatically that information is returned back into Witness. It gives us the full path name, which we would need if the Excel and the Witness model were in different directories, but for simplicity and portability I can quite easily delete that out. So I have my Excel read array, which specifies the name of the workbook, the name of the worksheet, and in this case the range that I have selected, and then the variable is going to place it in. I can do a similar thing for other information as well. So for instance, I could create a shift. Now I drag a witness shift onto my model. By default it is blank, and I can go into my actions, initialize, and again select from my Excel, and I can move to a shift sheet and select a shift pattern of my desire. Click OK, and again we have this time an Excel read shift command entered into the model. Just a variation on the read array which has a syntax set. And then if I were to restart my model and step forward and take a look at the result, I can see my shift has been populated. I can do exactly the same with a distribution. So if I go to an integer distribution, place it on the screen, by default it has no value. Go to actions, initialize, the Excel button, select the sheet I want, go to my distributions, select my information, click OK. We create an Excel read distribution, which again is just a variation on the Excel read array command. Take that out, click OK, and if I were to restart my model again, I should find that my distribution has been populated. And because this is done in initialize actions, it means I can make changes in my Excel spreadsheet to my data, to my shifts, to my distributions, and each time I restart the model, the new information will be brought in automatically. So it is a very convenient way of bringing data into the model. What I tend to do, and most of us in the office tend to, is having created our read arrays using those Excel buttons, which is probably the easiest way to do it, I would then copy them or cut them from that location and bring them together in my initialize actions, so I have one block of code where I do all my Excel manipulation. In this case we can see we have an Excel read array which is as initially set using those explicit cell references, but I can quite easily change it, because if I look in my Excel, I've chosen to make this, give this a named range with the name being M3_times, so I can quite simply substitute that in and I get exactly the same result. I've also got a setting in here where I can change how many M4 machines I want. The model currently has 2. Just click and check, there are 2 machines there, and if I go into Excel and change that number to 3 and I restart my model and step it forward, I can see I now have 3 machines in the model. And if I go back into my initialize actions, we can see that we use an Excel read array command, in this case to read in a single value. So it does not have to be a 2-dimensional array, a single value is sufficient. I read that into a variable, and then I use a set quantity command within Witness to set the number of machines that I want. So this means that as well as being able to read in as much data as I require from Excel, I can also configure the physical layout. I can add extra machines in, and change the quantity of machines and other elements. I can also change the capacity of buffers, and I can change the quantity of labour and the shift patterns that are working, all from outside of Witness, which is very valuable because it means that those of us who are writing models for customers to use can give a model to a customer who is not trained in Witness, and they can take it and use it simply by manipulating the Excel, and then they get the results automatically exported back out at the end. If I run this model for a little while, which is about the last thing I need to do because we're now 20 minutes into the presentation, I do have an export results, and I'm just going to drag this across to the right hand side, and if I set the model running, what is happening is every time my machine M2 is breaking down, I can see that I am getting a breakdown being reported out. Now, I've done something with my model at some point where I have managed to break the M3 machine. Let me just change that row to be a sequence next. So hopefully I can run my model now and get a little more traffic going through my M2 machine. I'm not quite sure what I've managed to do to the M3. It wasn't breaking down like that before. But we can see every time machine M2 breaks down, it is writing a report out to witness. And if I just stop it at this moment, every time it does a breakdown, and if I go into actions on breakdown, I am determining what the repair time is going to be from a distribution. I'm recording that on a histogram, and I'm also saving it as a dynamic variable in the model. Dynamic variables are very useful because they are self-sizing, which means we don't need to know how many records we're going to write before we run our model. In actions on finish of my breakdown, or actions end of my breakdown, I'm increasing a counter number of breakdowns that have occurred, and I'm using that to set my row number in Excel. So I then write out to my workbook M3 data, my sheet data out, and I'm writing to column A, and starts off as column A1, then column A2, column A3, the VI. This is my integer counter, which is going 1, 2, 3, 4 as breakdowns occur. I have to convert that into a string of text and concatenate it to get to my address, which is the way witness corresponds with Excel, and I write out the repair this time. So this is writing out a repair whilst the model is running, but I also have another stage that I have the model set to run to a defined end time. I'll just check what that is. It's 1 week. So if I run the model up to just ahead of 1 week and set it running to stop, the next thing is going to happen is this weekly report is going to be generated, and the weekly report is writing again with an Excel write array command, this time to column C, but rather than writing out individual results, it is taking all the values in our dynamic variable and writing them out in one go. So we need to specify the size of the dynamic variable, which of course can be changing, and I can use a max dim function in order to find out how big it is at the point I wish to write. And the result then is, if I click OK and step forward, that it writes out the same set of information that we can see in our dynamic variable in one go. This tends to be our favoured method of exporting data, simply because it's quicker, and because any time that witness is writing to Excel, and if Excel is otherwise occupied, there is a risk that communication may break down and you can lose a record. If that happens, you get a message from witness to say unable to write. You lose that export, but the model can continue quite happily. But for us, it's far safer to keep our information in witness and write out at the end of the model run for that extra security and for speed. Okay, I think I've pretty much run out of time. I hope what I've said has been of some interest to folk. So all I can say is thank you for your attendance. I hope it was useful. If you do have any more information you'd like, then send a message in and we'll deal with it offline either later today or maybe tomorrow. So okay, thank you very much for that. Any questions, please send them to chat, not privately to me, but to the main chat, and we'll deal with it very promptly. So thank you for your attention, and I wish you a good day.